this is a brand new technology to treat or abate odor, smell problems from wastewater treatment plant. Actually, well, it's my first time to Kuala Lumpur, Malaysia. And well, it's a pretty clean city and a lot of rain during the day. So, but at some point, I can also smell something from sewer systems, ventilations or grating systems, because something happened inside of the sewer. So we have to do something. So we started this project to develop the brand new technology with company name XEN. Well, it stands for Excellent Engineering. So probably they can provide you excellent engineering solution. I hope so. So to solve this problem, we applied the electrolytic. Well, it's not electricity. Electrolytic means separation of water by direct current. So using that electrical power, we try to remove the smell, odor problems from wastewater treatment facilities, usually from sewer pipelines and pumping station or manholes, something like that. Okay, so I'm gonna start with some introduction and how the system looks like and how it works and what is the kind of best good things in our system. We call this system XENEOS. Well, XN and also EOS means Electrolytic Oxidation System. So I call it XENEOS, okay? All right, some introductions. Well, as I mentioned before, there's some septic tank or collection well or pumping station and that kind of sewer systems, you can smell something. Sometimes it's really bad and sometimes it's okay, but still yucky, right? So we have to do something. What happened is, well, in the bottom of these kind of facilities, we have some kind of particles and also organic particles. That organic particle will decompose depending on temperature or oxygen content and many different factors. But usually that happens during the hot day or rainy day, depending on flow rate and everything. So we have to do something to control this odor from water treatment systems. Well, this figure shows that the number of public complaints go to the government office. Well, it's increasing quite dramatically. Even in year 2006, the Korean government collected more than 4,000 public complaints about smell from wastewater treatment facilities and also sewer systems. And that number keep increasing. Or even year 2010, more than 7,000. And I heard that number last year is greater than 9,000 complaints. Well, it's keep going up. So what's going on? What happened in Seoul? Well, back 10 years ago, people just, it's a smell, it's okay. But now, nobody actually pay attention. There's no tolerance on the smelly fume coming out of your ventilation or your drain or something. So you have to do something because a lot of people live in a big building and some smell coming out. Well, we have to do something. That's why they pick a phone and call a government and then we need something to do. So that's why we started this kind of project to develop the new efficient technology system for odor control. So the first thing we did, we went out to the power sewer pipelines and some septic tank installed in the hotel kind of building, and then checked what's the kind of concentration, smell concentration. So first thing is here, odor unit means dilution to threshold. So that number stands for how much clean water, clean air you need to bring down the concentration to under the detection level. So under the sewer pipeline, the odor should be diluted more than 40,000 fresh volume of fresh air to get the undetectable smell thing. So, and also ammonia, hydrogen sulfide, and many smelly compound is in high concentration. And also in the septic tank, the concentration varies quite a lot, huge or sometimes low, but usually we got lots of hydrogen sulfide and ammonia coming out. So we think, the source of the smell or the main compound of the smell is usually hydrogen sulfide or mercaptan or something, sulfur compound coming out. So what happened to the sulfur compound? Well, when you use that the soap or detergent, anything, that chemical contains sulfate. Well, this sulfate in the bottom of that some sewer pipelines, it actually changed to hydrogen sulfide or mercaptan or dimethyl disulfide, which is really smelly compound, depending on that the oxidation reduction potential. Well, in the bottom of the sewer, I mean, there's not much oxygen. So that compound will decompose and then kind of change to different types of sulfur compound, which cause you a really rotten smell. Oh, you know that what's that kind of smell like? You know. So this is kind of chain reaction. It coming in and out, and then it causes you a lot of kind of complaints. Oh, we have to do something. So conventionally, what happened? What would you do if your kind of drain or sink or sewer pipeline stinks? If you have a smell from your pipeline, what do you do? Like probably put a cap, seal? Yeah. Sealing is the best way. But if you seal here, probably smell coming out different drain or next one or your neighborhood. Well, not my problem. It's my neighbor's problem. So that is not a correct answer, I think. So well, the other thing is oxidant, like Clorox. What is that? The Rox, the brand name in Malaysia? It's Clorox? Clorox, yes. Yeah, you can dump Clorox. And then probably they'll remove some smell, but not all the time. Well, if you pour that, the Clorox probably takes a couple of days. But after that, still smell coming out. So that's why we need some efficient and economical and durable technology to keep the smell compound go away. Okay? So this is our solution. We picked and we chose electrolytic oxidation system. This electrolytic oxidation has, well, two electrodes, anode and cathode. I mean, if you go to your kind of high school chemistry class, probably you learn that the electrolytic, kind of separation of water electrolysis. So it's the same technology. Well, apply that the direct current power to the anode and cathode, and in the surface of anode, some odor compound is directly oxidized to sulfate or something like that. Or also, in the same reaction, we can get hydrogen peroxide, OCl or HOCl. That is a kind of the ROX compound, and actually that attacked smelly compound later, and actually reduced the odor cursing potential out of this wastewater. So we looked at the what's the kind of chemistry going on, and it looks really fine. So we decided, okay, it works. But if you applied huge power, like lots of power, that probably is not economical. You don't want to spend huge money on smell, destroyer. I mean, you want to keep a little bit small, kind of less money, and then keep this working, and then we minimize the smell coming out of your sink. That's it. So that's why we just try to supply minimum amount of energy, electrical energy, to this system, and then just keep smell problems away. That's our solution, and that's our goal for this project. Okay, so we can apply this to some. Oh, sorry. Okay. Yeah, apply this system to like a septic tank, pumping station, or wastewater storage tank, something like that. Or I think I have a great idea. Before my presentation, the speaker talked about kind of rain harvesting thing. Probably in the rain harvest tank, well, if you keep the rain, collecting rain for a while, I mean, probably some kind of, smell thing coming out. I'm not sure, but that's quite possible kind of phenomena, I think. So we can apply this kind of technology to minimize the odor problems. Anyway. So this project was done by the company named XEN, and also the university. It's a kind of academia and industry collaboration, and also it's funded by the Korean government to support this kind of research. And the system looks like this, and we need electrode. So we added kind of a dimensionally stable anode and stainless steel to minimize the cost of the electrode. Well, one of the key points of this technology is what type of electrode we're going to use, because we want that this system go almost forever. So electrodes should be durable and stable and work continuously all the time. So that is the kind of electrode system we designed. And there's the power supply and also electrochemical sensor to detect what is that the hydrogen sulfide and other compound coming out of the water. So we keep measuring this kind of concentrations as well. And also circulations and monitoring system. So in overall, it looks like this. In a septic tank or collecting well or water storage, wastewater storage tank, we put this kind of circulation pump and electrode and control systems and the measuring device inside. So we can kind of measure what's the concentration changes depending on that the water flow in and out to this septic tank or collecting well. Okay, let me show you that what the system worked. I mean, performance evaluation. First, we did a preliminary lab test. So we got this wastewater, bring to the lab, and then try to see what's going on. So we used the titanium oxide and then stainless steel as an electrode, and then applied about 20 volt of direct current and measured the concentration changes over the time. Well, this is the kind of preliminary data, and we operated this closed box system for 2 hours, 120 minutes, and this red circle shows that the hydrogen sulfide concentration in the headspace. Think about it. You have a really stinky, really high concentration wastewater. Put it into the small chamber box, and then agitate it and mix it a little bit. So the smelly compound in the headspace, really, the concentration went up really high. So the concentration is about 500 ppm. Well, I'm really sure that you don't want to smell this 500 ppm of hydrogen sulfide. This really stinks. So, well, we applied the direct current, and then concentration dropped quite quickly. After 30 minutes and 40 minutes, the concentration dropped below the detection limit. So it's gone quite quickly. And also what happened on the liquid phase is, this blue circle shows that the sulfate ion concentration. So that means hydrogen sulfide would oxidize to sulfate. It proved that the system actually do some oxidation power. And also, in the same time, oxidation reduction potential, which means how much kind of oxygen in it. It shows that it's going up, so it keep the concentration, odor causing potential as low as possible. So, based on that kind of preliminary lab test, we tried to design a real system. So first we tried apply this system as a pilot scale. So this is about 10 cubic meter per day scale flow rate, and then usual COD going into this system is about 500 milligram per liter. And this is what we designed for this kind of try to smell compound. So this power we applied was 0.18 kilowatt. So it's about 180 watts. So probably same as 2 of that electrical bulb up there is 180 watts. So you can use 60 watt, the 3 bulbs of 60 watts. So it's not that much. And this is the real data. And this data is controlled. So without our kind of system, so we measure that continuously what's going on over the 3-day period. So in the septic tank, wastewater coming in and out, so hydrogen sulfide concentration on the headspace of the reactor is up and down a lot. Well, usually the odor characteristic is it's not always stable. It's up and down a lot because some kind of chemistry going on and then biological activity going on. So that's why the concentration went up and down a lot. But generally, the concentration from around 2 or 3 ppm to up to 40 ppm is up and down a lot. When we applied our XENEOS, the concentration dropped dramatically, a little bit up a little bit, but it was maintained kind of less than 3 ppm. So it's quite happy about it. Okay, yeah, we proved it works. So this is a summary. And odor unit, and the highest volume was about 30,000. It dropped to less than 100. And then also hydrogen sulfide concentration dropped quite dramatically. So based on that kind of technology evaluation, okay, it's time to go out for the real application. This is a kind of city building, and in front of the city building, there is a kind of, you can see that the manhole, it's a water collecting well, wastewater coming in first and then go out to the street, the pipeline. So from this manhole, well, it's quite bad smell coming out all the time. Well, not all the time, it's up, down a little bit, but usually at the high period, it means really stinky. So we tried, we applied our system inside of this manhole, and of course, the concentration dropped quite dramatically, and we were really happy about it. And this is a kind of year-long system operation. We started this year 2013, February, and before the installation, the concentration is really high, and then it dropped, so less than 3 ppm. So during this period, we just kind of turn it off to see what's going on, and the concentration went up quite, and then after that, the concentration was maintained below 5 ppm. So it's quite okay. The smell problem's gone, so complaints gone. Well, smell compound still left a little bit, but generally, nobody complained about it. So we operate this like until that the year 2014, February, and then it going up a little bit more. So year-long application shows, well, it worked for a long time. Well, after that, we also kind of tried, oh, yeah, this is an on and off system. So we better do something better. So that is a kind of automated system. Well, we call it, smart. I don't know what we call it, smartphone and smart system. And well, smart means smart, right? But anyway, automatic system, we call it smart way. So we added that some kind of control logic and also measuring device to see what's going on inside of the system. So this data looks like what's happening during this 1.5-day period without XENEOS, with on and off style. This is automatic control system. Depending on the temperature and concentration, flow rate, we increase the voltages and flow rate on something and then try to always keep the concentration low. So as you can see, the automatic system get really high, low concentration of odor compound coming out from that system. So, well, it works. So we try to make on and off system. If you want, just, okay, I just want to turn it on and just forget about it. Or sometimes we can put that the automated system to make it the system smart, right? So let me summarize what our kind of brand new technology looks like. First, the application is a little bit different. The electrolysis system has been used for drinking water, for disinfection, for a long time, like more than a decade. But now we can use this kind of low energy electrolytic system to smell odor abatement process. And also this process is quite safe. Well, you have to use some kind of Clorox or something or some oxidant to kill or destroy the odor compound out of the sewer system. So we can use this low energy electrolysis system to minimize the kind of safety issues. And also we developed the automated control system. I think it works better for just a kind of on and off kind of style operation. And also in this wastewater treatment, we didn't use electrolyte. So sometimes for electrolysis system, people use salt, kind of table salt, or some kind of chemicals to increase the activity or kind of performance. But in here we have a lot of kind of salt, ionic compound inside of the wastewater. So we did not need to use the electrolyte. Also, sometimes people use the membrane to separate the anion and cation activity, but we don't need to use this kind of membrane as well. Okay, and also it's quite durable. As I show you a year-long experiment in the field application, so we can apply this system for more than a year. Well, we think we can do with the proper maintenance, so we can kind of use this system more than 3 years. So you turn on, forget about it, and it works fine to remove the odor problems from your sink. And also, it's a kind of, we apply that the electrode is quite long-lasting electrode, so it works fine. But you have to do some cleaning kind of regularly. But other than that, it worked okay. And also, for this system, like kind of about 100 cubic meter per day, we need kind of 0.7 kilowatt hour. So electricity is not that much. Well, if you remove everything from the wastewater, you have to put really high energy. But we wanted to just kind of remove smelly compound alone. That's it. So using this low energy, we think we achieved our objective, our goal to remove the odor problems. Well, this is the kind of price. And our system usually for the 10 cubic meter per day scale is around 10,000 US dollar, and the maintenance is about $1,800 a year because it just clean up the electrode surface regularly, and that's it. But if you want to do some oxidant like a Clorox supply, probably it requires more than a 15,000 US dollar device to spray the Clorox regularly to the inside of the pipeline. So that's why you have to use kind of quite a money, and also maintenance costs you a lot because you have to refill the Clorox to the storage tank kind of regularly. That's why the oxidant application costs you a little bit more than our system. We got actually 3 Korean patents and also applied at the one patent to US patent. And also, as I mentioned before, we got also we worked with the Korean government environmental technology verification process. We got this kind of certificate of this kind of Korean environmental ETV kind of certificate from the Korean government. So it's proven technology, and we also did 1 year long field kind of test. So I think it's a kind of good technology and brand new technology you can apply in your home country and for your building or for your apartment buildings or your home or city centers and something like that. All right? Okay, thank you for your attention.